The process of connecting to a wireless LAN is only going to be completed after the client has properly first located their access point and identified, if there were multiples, which access point they're going to connect to based upon the throughput and, of course, the bit error rate. However, the client must actually complete 2 more layer 2 processes before this whole process is finished, and that involves authentication and association. I do not want you to get confused with authentication because we have user-based authentication, which happens at the higher layers, but we also have, of course, the layer 2 authentication, which is authenticating to the access point itself. These processes have to be completed for the client to finalize their connection to the AP. The first step in connecting to the wireless LAN is authentication. Authentication is actually the process where a wireless node is going to have its identity verify the network, which is normally the access point. This verification will occur when the access point to which the client is connecting verifies the client is who it says it is. To put it another way, the access point responds to client requesting to connect by verifying the client's identity before any connection at all is going to happen. Sometimes the authentication process is considered null, meaning that although both the client and access point have to proceed through this step, there is no authentication or no specific identity required for association. This is the case when most brand new access points are taken out of the box and are left in their default configuration with no additional security measures being implemented on them. Whether or not the process is null, we still have to carry the process out. The client begins the authentication process by sending what's known as an authentication request frame to the access point. The access point will either accept or deny this request, thereafter notifying the station of its decision with an authentication response frame. The authentication process can be accomplished at the access point, or the access point might even pass along this responsibility to an upstream authentication server, such as Radius, the remote authentication dial-in user service. Radius server would perform the authentication based upon a list of criteria that you as an administrator can specify, and then return its results to the access point so the access point can return those results to the client station. There is a variety of things that a Radius server can apply, and that includes things like MAC address authentication, even the synchronization and broadcast rotation of web keys. These are all things that we get a chance to discuss later on in the series in wireless security. Beyond authentication, we also have to go through the association process. Once a wireless client has been properly identified or authenticated, the client will then associate as a second phase with the access point. Associated is the state at which a client is allowed to pass data through an access point. So if your PC card is associated to an access point, you're officially connected to that access point and you are being bridged to the back-end network. The process of becoming associated is as follows. When a client wishes to connect, they send an authentication request to the access point, and in response will receive an authentication response frame. After authentication is completed, the station will send an association request frame to the access point, who in turn will reply back to the client with an association response frame, either allowing or disallowing association. Now, there are going to be some states of authentication and association that you have to worry about. And the reason why you have to worry is because, well, some of these can lead to significant problems when trying to connect to your network or understand why a particular client has only proceeded through part of the process and not really being able to figure out why a client is unable to transmit data, or even in more simple terms, is not able to receive an IP address from the back-end network. The states of authentication and association include, first, unauthenticated and unassociated. And just like what it says, nothing has happened. The wireless node is completely disconnected from the network and is entirely unable to pass any frames at all through the access point. Access points will keep a table of client connection statuses, which is known as the association table. Very important to note is that different vendors refer to the unauthenticated and unassociated state in their access point association table quite differently. The table will typically show unauthenticated for any client that exists in this particular state. We also have a second state which is known as authenticated and unassociated, which is just like it states. They have finished phase 1 but have not yet completed phase 2. The wireless client has passed authentication. The client is not yet allowed to send any data or receive any data through the access point. The access point's association table as well will typically show authenticated. But because clients pass the authentication stage and immediately proceed into the association stage very quickly, in milliseconds, rarely do you see authenticated step Rarely do you see that the authenticated step has been completed properly on the access point. It's far more likely that you will see unauthenticated or associated, which actually goes into the last phase. Authenticated and associated is the third and final state of these two modes. Your wireless node at this point is completely connected to the network and is able to send and receive data through the access point to which the node is connected. You will likely see associated in the access points association table, denoting that the client is fully connected and is authorized to pass traffic through the access point. But as you can see from the description of each of these three states, advanced wireless network security measures would be implemented at the point in which the client is attempting to authenticate. What we sometimes find is that a client can see the network, is actually receiving and sending appropriate probe frames as well as beacons, but it's unable to authenticate due to some extreme security measures, like not being able to match on the web key or the MAC address not being properly specified. So we need to make sure that we understand that we're either going to have no association or we're going to have full association if all security checks have been passed and all of our previous elements have been matched properly, like the service set identifier. There are going to be several authentication methods that we should get used to as wireless LAN administrators. The 802.11 standard specifies two different methods of authentication, and mixtures of these can actually cause problems on your wireless network, so it's a good idea to understand both of them fully. The two different types are open system authentication and shared key authentication. The simpler and also the more secure of the two methods is open system authentication. For a client to become authenticated, the client must walk through a series of steps with the access point. This series of steps will vary depending upon the authentication processes that you have put in place. However, it's very, very important that we understand open system authentication because this is the preferential method that we want to use in most of our secure wireless networks. This is also the default setting in wireless LAN equipment. Using this method of authentication, a station can associate with any access point that uses open system authentication based only on having the right service set identifier. The service set identifier must match both on the access point and the client before they're allowed to complete the authentication process. The open system authentication process is used effectively in both secure and in non-secure environments. But the real beauty of open system indicates that the client has specified the wireless access point. They have actually identified what connection they want to make, versus using shared key authentication, which does not do this. We want to look at a little bit more detail, though, at the open system process. The wireless client will make a request to associate to the access point based upon the service set identifier. The access point will then authenticate the client and send a positive response, and the client can become associated. It is very simple, but as the wireless LAN administrator, you've got tons of options as far as how you can secure your open system, such as using WEP keys, wired equivalent privacy. If WEP is used with the open system authentication process, there's still no verification of the WEP key on each side of the connection during authentication. However, the WEP key is used for encrypting data once the client is authenticated and associated. The one thing that's really interesting about WEP keys, as you begin to add this type of security to your network, you may notice that a fully associated client is unable to exchange data, even data with the DHCP server. That typically indicates that the client is properly authenticated and associated, but the WEP key is wrong, and they are unable to decrypt any data that's being sent via the access point because the WEP key is off. Open system authentication is used in several scenarios, but there's really two main reasons to use it preferentially over shared key. First, open system authentication is considered the more secure of the two available authentication methods. And the main reason is because what we see with shared key authentication is that a clear text challenge and the same challenge encrypted with the WEP key is sent during the initial authentication process. Now, if you're a hacker and I've actually got a message that's clear text and I know that the same message is actually being sent encrypted with the WEP key, doesn't make it too difficult for me to reverse engineer that key, reverse engineer that message. And that's being able to derive the WEP key that actually makes the shared key authentication less secure. With open system authentication, it's very simple, and that's the second reason why a lot of organizations prefer to use it, is that it is very, very easy to configure because it really doesn't require any configuration at all. We don't have to worry about the WEP key needing to be agreed upon before the first